Welcome to everyone. This is Dr. P Saranya, Assistant Professor, PG and Research Department of Mathematics, Sri Sharada College for Women, Autonomous, Salem. In this video, we are going to see the topic about hyperbolic functions and inverse hyperbolic functions. First, we see the definition for hyperbolic functions. For real or complex z, the function e power z minus e power minus z by 2 and e power z plus e power minus z by 2 are defined as sine hyperbolic functions and cosine hyperbolic functions of z respectively. And it is denoted by sin hz for sine hyperbolic functions and cos hz for cosine hyperbolic functions. That is sin hz equal to e power z minus e power minus z by 2 cos hz equal to e power z plus e power minus z by 2. Similarly, tan hz equal to e power z minus e power minus z divided by e power z plus e power minus z. Next we see the relation between circular and hyperbolic functions. In that sin ix equal to I sin hx, cos ix equal to cos hx, tan ix equal to I tan hx. Next we see some addition formula for hyperbolic functions. First one, sin h x plus y equal to sin hx cos hy plus cos hx sin hy. Next one is cos h x plus y equal to cos hx cos hy plus sin hx sin hy. Tan h x plus y equal to tan hx plus tan hy whole thing divided by 1 plus tan hx into tan hy. Next we see an example problem for hyperbolic function. If sin a plus ib equal to x plus iy, prove that x square by cos h square b plus y square by sin h square b equal to 1 and x square by sin square a minus y square by cos square a equal to 1. First we see the solution for subdivision 1. Let us take sin a plus ib equal to x plus iy. And when substituting the formula sin a plus ib, sin a cos ib plus cos a sin ib equal to x plus iy. Sin a cos ib is nothing but cos hb plus cos a sin ib is nothing but sin hb equal to x plus iy. Consider this is equation number 1. Next, you have to equate both real and imaginary parts on both sides. Sin A cos HB equal to X. Similarly, cos A sin HB equal to Y. Consider this is equation number 2 and this is equation number 3. You have to squaring and adding on equation number 2 and 3. We get sin square A cos h square B equal to x square cos square A sin h square B equal to y square. From this x square by cos h square B equal to sin square A. This is equation number 4. Similarly, y square by sin h square b equal to cos square a. This is equation number 5. Add equation 4 and 5. Add equation 4 and 5. We get x square by cos h square b plus y square by sin h square b equal to sin square a plus cos square a. sin square a plus cos square a, which is equal to 1. Next, we have to prove the subdivision 2. Subdivision 2 is x square by sin square a minus y square by cos square a equal to 1. Here we see already we find sin square a cos h square b equal to x square. From this, we have taken x square by sin square a equal to cos h square b. Consider this is equation number 6. And the next one is y square by cos square a equal to sin h square b. Consider this is equation number 7. Subtract these two equations. Finally, we get x square by sin square a minus y square by cos square a equal to cos h square b minus sin h square b. This is nothing but equal to 1. Next, we see the another problem for hyperbolic function. If u equal to log tan pi by 4 plus theta by 2, show the first subdivision tan h u by 2 equal to tan theta by 2. And then second one is theta equal to minus I log tan pi by 4 plus I u by 2. First, we see the solution for first subdivision. Let us consider u equal to log tan pi by 4 plus theta by 2. Taking e on both sides, e power u equal to e log tan pi by 4. Taking e on both sides, e power u equal to e power log tan pi by 4 plus theta by 2. From this, e power u equal to tan pi by 4 plus theta by 2. Already we know one formula. Tan a plus b equal to tan a plus tan b whole thing divided by 1 minus tan a tan b. Here you have to take an a equal to pi by 4 and b equal to theta by 2. So substitute this value in this above formula. Tan pi by 4 plus theta by 2 equal to tan pi by 4 value is 1 plus tan theta by 2 divided by 1 minus tan pi by 4 value is 1. So tan b value is tan theta by 2. So e power u equal to 1 plus tan theta by 2 whole thing divided by 1 minus tan theta by 2. First, we have to find out the value for e power u minus 1 equal to 1 plus tan theta by 2 divided by 1 minus tan theta by 2 minus 1. So e power u minus 1 equal to 1 plus tan theta by 2 minus 1 plus tan theta by 2 whole thing divided by 1 minus tan theta by 2. From this, here one value is get cancelled. So 2 tan theta by 2 divided by 1 minus tan theta by 2. Similarly, we have to find out the value for e power u plus 1. So 1 plus tan theta by 2 by 1 minus tan theta by 2 plus 1, which is equal to 1 plus tan theta by 2 plus 1 minus tan theta by 2 whole thing divided by 1 minus tan theta by 2. From this, tan theta by 2 get cancelled, remaining 2 by 1 minus tan theta by 2. Now e power u minus 1 by e power u plus 1 equal to 2 tan theta by 2 whole thing divided by 1 minus tan theta by 2 divided by 2 by 1 minus tan theta by 2. This 1 minus tan theta by 2 get cancelled. Remaining thing is 2 tan theta by 2 divided by 2. From this finally we get the answer is tan theta by 2. This e power u minus 1 it can be written as e power u by 2 by e power minus u by 2 minus 1 by e power u by 2 by e power minus u by 2 plus 1. This is nothing but e power u by 2 minus e power minus u by 2 by e power u by 2 plus e power minus u by 2. This is equal to tan theta by 2. Left hand side is a formula for tan h u by 2. So this is tan h u by 2 equal to tan theta by 2. So we proved that first subdivision tan h u by 2 equal to tan theta by 2. Next we see the solution for second subdivision, that is theta equal to minus I log tan pi by 4 plus I u by 2. In first subdivision tan h u by 2 equal to tan theta by 2. Already we known formula is tan ix equal to I tan hx. So you have to substitute this in this equation. So tan I u by 2 equal to I tan h u by 2. So from this tan h u by 2 equal to tan I u by 2 by I. So you substitute in this above one, tan I u by 2 divided by I equal to tan theta by 2. So from this tan I u by 2 equal to I tan theta by 2. Adding 1 on both sides. So 1 plus tan I u by 2 equal to 1 plus I tan theta by 2. Uh, Similarly, 1 minus tan I u by 2 equal to 1 minus I tan theta by 2. You have to divide these two 1. So 1 plus tan I u by 2 whole thing divided by 1 minus tan I u by 2 equal to 1 plus I tan theta by 2 divided by 1 minus I tan theta by 2. So tan pi by 4 value is equal to 1. So you have to taken the known formula. The above one is 1 plus tan iu by 2 divided by 1 minus tan iu by 2. Already we know that tan pi by 4 value 1 which is equal to tan pi by 4. So we know formula is tan a plus b equal to tan a plus tan b divided by 1 minus tan a tan b. So rewrite in the rewrite using that formula, tan pi by 4 plus I u by 2 equal to 1 plus I tan theta by 2, 1 plus I tan theta by 2 divided by 1 minus I tan theta by 2. This is nothing but 1 plus I tan theta by 2 is equal to sin theta by 2 by cos theta by 2. Similarly, 1 minus I sin theta by 2 by cos theta by 2. And then solve the above one. What we will get means cos theta by 2 plus I sin theta by 2 whole thing divided by cos theta by 2. Similarly, cos theta by 2 minus I sin theta by 2 the whole thing divided by cos theta by 2. Cos theta by 2 cos theta by 2 get cancelled. Remaining thing is cos theta by 2 plus I sin cos theta by 2 plus I sin theta by 2 whole thing divided by cos theta by 2 minus I sin theta by 2. Tan pi by 4 plus I u by 2 which is equal to cos theta by 2 plus I sin theta by 2 divided by cos theta by 2 minus I sin theta by 2. Take conjugate on cos theta by 2 minus I sin theta by 2. So cos theta by 2 plus I sin theta by 2 divided by cos theta by 2 plus I sin theta by 2. From the in numerator cos theta by 2 plus I sin theta by 2 the whole square divided by here cos square theta by 2 minus I into I square value is equal to 1 plus sin square theta by 2. So denominator value is equal to 1. So tan pi by 4 plus I u by 2 equal to cos theta by 2 plus I sin theta by 2 the whole square. Already we know that e power I theta equal to cos theta plus I sin theta. So you have to take here e power I theta by 2 equal to cos theta by 2 plus I sin theta by 2. So you have to substitute tan pi by 4 plus I u by 2 equal to e power I theta by 2 the whole square. This is nothing but e power I 2 theta by 2 from this e power I theta. So taking log on both sides, log tan pi by 4 plus I u by 2 equal to I theta, and then theta equal to 1 by I log tan pi by 4 plus I u by 2 multiply and divided by I theta equal to I by I square log tan pi by 4 plus I theta I u by 2. So theta equal to minus I log tan pi by 4 plus I u by 2. See inverse hyperbolic functions. If y equal to sine hx, x is called the inverse hyperbolic sine of y and it is written as x equal to sine h inverse of y. Similarly, y equal to cos hx, x is called the inverse hyperbolic cosine of y and it is written as x equal to cos h inverse of y. And also we have to write y equal to tan hx is an inverse hyperbolic tangent of y and it is written as x equal to tan h inverse of y. Let us now express sin h inverse of x in an logarithmic functions. So first we take let y equal to sin h inverse of x. From this x equal to sin hy. Already we know that sin hy equal to e power y minus e power minus y by 2. From this 2x equal to e power y minus this can be written as 1 by e power y. 2x equal to e power 2y minus 1 by e power y. And this is 2x into e power y equal to e power 2y minus 1. From this e power 2y minus 2x e power y minus 1 equal to 0. You have to use this quadratic equation and find out the value for y. This is in the form of quadratic equation. So you have to use the formula for quadratic equation minus b plus or minus root of b square minus 4ac by 2a. So here you have to substitute in the equation. So e power y equal to 2x plus or minus root of 4x square minus 4 into minus 1 by 2 into a value is 1, so 2. So here 2x plus or minus root of 4x square plus 4 by 2. Here you have to taken 2 on outside equal to 2x plus or minus root of x square plus 1 whole thing divided by 2. So 2 get cancelled. From this e power y equal to x plus or minus root of x square plus 1 taking log on both sides. Since e power y is positive for any real value of y, so e power y equal to x plus root of x square plus 1. Taking log on both sides, what we will get y equal to log x plus root of x square plus 1. Thank you.